As we know, a physical robot or even a software conversational agent can interact with humans via voice or simply text. When using voice, we've seen that there is a first step that is automatic speech recognition or speech to text translation that will translates the sound of the voice into plain text. After that step comes what is called natural language understanding. Although the word understanding is a bit exaggerated or a bit misleading, because to be honest, a robot or an algorithm does not really or deeply understand the text it receives. But what is true is that the robot can get enough information from that text to act accordingly with what the human is saying. Well, the processing done in natural language understanding involves several steps. Usually, first step is what is called tokenizing. Tokenizing is dividing the text into small elements, small components called tokens. You can think about a token as a word, because usually a word gets converted into a token, but that's not always so. If, for example, in the case of birds, it's common dividing the simple word, the verb, in two parts, two tokens. The root of the verb, that's the main meaning, let's say, and the ending that gives information, for example, about the tense. Or in the case of proper names, tokenizing usually involves considering each single character due to spelling. Well, after we have done tokenizing, the next step is creating embeddings. Embeddings are just, or the process of getting embeddings is translating words or tokens into vectors. Vectors in a high-dimensional vector space. Getting vectors is not only useful because of mathematical reasons, because AI algorithms use vector matrices, tensors, and the like, but also because embeddings give more information. If the vectors representing two different words, two different tokens, are close to each other, that fact is giving us some information that those words, let's say, are somehow related. Maybe there's a syntactical relation between them. Maybe they are close in meaning, or just that they are commonly used together. Well, after we have that vectors, that embeddings, comes let's say, the real algorithms that is done via neural networks or deep learning. Maybe you remember recurrent neural networks that were used mainly in the past for natural language understanding. And if you remember, recurrent neural networks had kind of a memory or context, but a very small or short context. To express it some way, the neural network could remember, let's say, the previous word. But modern algorithms in natural language processing, coming mainly from the area of generative AI, or for example, transformers, use a new mechanism called attention. Via attention, the context is much greater, so the algorithm can take into account, let's say, a lot of previous words. Well, after doing that, the robot or the algorithms has some information, and via natural language understanding, a robot or software agent can extract information, for example, about the intention of the speaker, as is done in traditional chatbots, or named entities as cities or characters, or the robot can extract keywords for a search, or can do a sentiment analysis, or can even just extract a prompt to use it in a generative AI algorithm. But that's another step. Let's consider the robot, through natural language understanding, now has some information about the meaning, about what the human is saying. Well, now the robot must give an answer, but about creating output, creating text, or creating voice, will speak in future videos.